All right, so last time we left off with number 7, I believe.
Okay,
Remember number 7?
barely. The remainder when n is divided by 12, and then when divided by 18.
And we know that n is divisible by 6. So n can only be 6, 12, 18, 24, 30, and so forth.
Uh-huh.
All right, let's go on to number 8. Now, most of these problems, I would say I have to solve by plugging in numbers. But not this one. This one is a straight algebra problem. In other words, we have an equation. We can solve for x. How do I solve for x? In other words, whenever you have an equation with one variable only, you can always solve it 100% of the time. So we can solve it, and then we'll be able to compare quantity A with quantity B.
Can you hear me?
I can. Can you hear me?
Okay. Yeah, I had unplugged my headphones, so.
Those headphones are kind of tricky. I've heard from other students that if you don't plug in the headphones prior to logging in to go to meeting, they don't work. So
That's what I just observed.
Yeah, I don't know what happens if you have them plugged in and you unplug them and replug them back in. But
It tries to download some new program or whatever.
okay, well, it seems to be working just fine now.
Yep.
Let me turn my volume up because actually I had my volume down, so that probably didn't. All right. So let's solve this equation. It's definitely the way to go about doing this problem. Only because I'm looking at one variable, one equation, I know I can solve it.
Okay.
How do you solve it?
Well, plug in numbers, right?
No, not in this case. In this case, this is quite an easy algebraic equation to solve. In other words, plugging in numbers could take a lot longer here. There are some problems that are not easy to solve algebraically, where the best method that I have found is plugging in numbers. But this one's not one of those. This is relatively easy. You got to be able to solve for x. First thing let's try is cross multiplying. Whenever you have a fraction equals a fraction, you can always cross multiply. Okay?
So 1 minus x squared?
Well, let's just do it step by step.
Okay.
You with me?
Yes.
Now let's distribute. Still with me? Now let's subtract x from each side, which gets rid of that and gets rid of that, and leaves minus x squared equals minus 1.
Okay.
Means now if I divide both sides by minus 1, I get x squared equals 1. Now what is x equal to if x squared equals 1?
X equals 1.
It's actually plus or minus 1.
Well, that's right.
And that's the key to this whole problem. Because if you get 1, you're going to get the wrong answer. If you get 1, you're going to say quantity A. But
Right.
if you get plus or minus 1, well, then you're
It's
going
going
to
to
say
be
you can't determine it. Because if
right.
it's minus 1, then B is larger.
Right.
So the plus or minus is everything on this problem. And what I basically tell my students, like I said, I wish I had a song to sing, but if you're solving, hold on, if you are ever solving an equation by taking the square root of both sides, like this equation right here,
Yes.
always begin your answer with the words plus or minus. Always, 100% of the time.
Okay.
Okay? And problems like this, you're going to get wrong if you don't do it, I can assure you. That's the whole
Right.
essence of this problem, is to make sure you came up with the plus or minus 1. Because plus or minus 1, we don't know. If it's minus 1, it's less than B. If it's plus 1, it's greater than B.
Okay. So because these are two fractions, that's why I have to do it algebraically and do the cross multiplying?
Yeah, I would say that whenever you see two fractions, let's say I had something like this, just cross multiply automatically.
Okay.
Which gives you 5 equals 3 times x minus 1, which gives you 5 equals 3x minus 3, which gives you 2 equals 3x, which gives you x equals 2 divided by 3.
Right.
So when you see a fraction equals another fraction, even if there's variables everywhere, cross multiply.
Okay. Thank you.
All right. It's the median of those three numbers that I just wrote.
I'm sorry?
What is the median?
Oh, I didn't. I thought you weren't finished with your sentence.
No.
The median?
It's the middle.
Right.
So it's 3.
Mm-hmm.
If I give you an even set of numbers, now the median is not a number, it is halfway in between the second and the third number. So the median with these 4 numbers would be 5.
Right.
So it kind of depends on whether it's odd or even. If it's odd, you take the middle number. If it's even, you take the average between the two middlest numbers.
Okay.
Okay. Well, in this problem, they're saying that we have 12 numbers to the left of 50, and we have 12 numbers to the right of 50. So let me take a shortcut here. So there's 12 numbers in that group, there's 12 numbers in that group.
Correct.
What's the median?
50?
Correct. But what if I make this 47, and I make that, leave it the same? Now what's the median?
49.
So what's the answer to this problem?
It's not definitive.
Exactly. In other words, had they given you an odd number of numbers, then the median is always definitive. It's always the middle number.
Oh, okay.
Okay, but when they give you an even set of numbers, the median is the average between the 12th and the 13th number. So depending on what the 12th number is and what the 13th number is, affects the median.
Right.
And we can't tell here whether the median is going to be less than 50, greater than 50, or equal to 50.
Okay.
This is also fairly straightforward. By straightforward, I mean you can do this algebraically, and it's the best way to do it. There are questions here where the only way I can figure out how to solve them is to try a bunch of numbers. And you kind of have to get the hang of which those questions are and which aren't.
Okay.
It's algebraic. It's a word problem. So we can actually work through this from the beginning sentence to the last sentence.
Okay.
So if each curtain is 1.6 yards, how much fabric do I need to make 3 curtains? What would be the minimum amount of fabric?
So it would be 1.6 times 3, right?
Which is 4.8 yards. But they say that you have to purchase it by the full yard. So what would we have to purchase?
5.
$8 per yard. What are we going to have
That'll be $40.
This is one of the easier ones that I've seen.
Yeah.
But they do get harder, starting with here.
Now, this is a paper test, and I've heard that the computer test, it adapts to how you answer the question. Is that correct?
I've heard of tests like that before. And what that means is that if you get the first 10 questions wrong, you're getting an easy 11th question. If you get the first 10 questions right, you're getting a hard 11th question.
Okay.
That's what it means by adapting.
Right.
In other words, it's going to change the questions you get depending on how well you do.
Right.
And you might think that that would be a horrible way to come up with a test score, or maybe unfair, but they work it out. They figure out how to grade it. In other words, the harder questions, you might get a little bit of a weighted score. So that if you get a harder question correct, it counts more than if you get an easier question correct.
Correct.
Now, I didn't realize that GRE was like that.
Yeah.
So if it is, I'm not sure it really affects us much in the way we're going to train you to take it. Because we still have to cover easy, medium, and hard questions.
Right.
And I don't know how I would even change my tutoring plan if that was truly the way the test was scored.
Yeah, because I had a question about whether, I think per section I can skim through and see what the questions are, but if it adapts, it's not going to be the same question.
Well, if it adapts, you're never going to see the next question. In other words, if it really is an adaptive test, they're going to show you the current question only. And then
Yeah, and
depending on whether you get it right or wrong, the next question will change.
right, and that's one of my concerns, because some of the strategies that I've seen in some of these books have said, do the easy test first, and that makes it sound like you can skim ahead. So I don't know. I'll have to download one of the practice tests from GRE and see what it does.
Any strategy that tells you to do the easy test first, I don't disagree with, regardless of their reasoning.
Right.
I absolutely think that if you're trying to get the maximum score on this test and that's the only thing you care about, then you want to do the easy test first, the medium test second, the hard test last.
Right.
That's just what I believe. Now, maybe if the hard test was worth 5 points per successful question and the easy test was only worth 1, I might change my opinion. But without knowing anything about the, what they give you credit for when you get a hard question, as opposed to what they give you credit for when you get an easy question, I wouldn't really be able to answer that. Obviously, if you got, say, 1 point for an easy question and 100 points for a hard question, well, then I would say spend all your time on the hard questions. So it really kind of matters on how they weight them. If they really do it the way you're suggesting they do, they would have to score hard question successes higher than easy question successes.
Yeah.
And like I said, I'm not sure that it matters for the way we're going to prepare you for it. I can't imagine what I would do different. I really can't. I would still concentrate on all the easy ones, next on all the medium ones, and next on all the hard ones. And I'm not really even doing that. I'm kind of going through them in order, and we're going to run into hard ones and easy ones and medium ones.
Yes.
So if I actually were going to come up with a plan, I would say let's do 20 easy ones and then 10 medium ones and then 5 hard ones.
Okay.
But I'm not even sure that that would be correct, because I don't know what they credit you with when you get a hard one correct. Or if you miss a hard one, they may not take away as much. They could have a very sophisticated way of grading it. So I don't know of any other way to just cover as many questions as we can.
No, that's fine. I was just curious, that's all.
Yeah, I wish I could answer it. I don't really know. I don't know if it's computer adjusted. It seems like the GMAT student that I had that I worked with for like 4 years, he would do that every now and then also. But that was a while ago. That was like 4 years ago. So I don't honestly know how the test is applied today.
Alrighty.
All right. So this next one, 11, is a little tricky. First of all, let me make sure you understand positive slopes and negative slopes. Tell me which of these are positive and which are negative.
I'm guessing that's positive.
Okay.
Negative. Positive.
Horizontal line.
Neutral.
0.
No slope.
It's actually 0. It's not, I mean, there's a difference between neutral and 0. That's a 0 slope.
Okay.
A vertical line.
100? I don't know.
Well, you're close. It's actually undefined, and it's actually infinite.
Oh, okay.
It's infinity. It's extremely large. Okay. All right. So you know slopes. Now let's look at this problem. This is not a particular easy problem. How come this isn't working? Okay, I get it now. I can't write outside that boundary. The only thing they say is it does not pass through the origin.
Okay.
The x-intercept of line K is twice the y-intercept. Well, let's draw a line like that. Notice my x-intercept is about twice that y-intercept.
Okay.
Well, that's a negative slope, right?
Yes.
Okay, so I would be tempted to say yes to A based on my picture. But that's not really the way to prove that it is individually sufficient. What you really want to try to do is see if you can draw a positive line, positive slope, where the x-intercept is twice the y-intercept. And if I can do that, I can prove this wrong.
I don't see that you can.
You're right. I don't think you can. In other words, I looked at this problem a lot. And if I try to do, and remember, I've got to try a positive slope. Okay? So if I put a positive slope like that, well, the x-intercept is, let's say, 2. The y-intercept is -4. Well, the x-intercept is not twice the y-intercept. Twice the y-intercept would be -8. And even if I make that 4 and that -2, well, the y-intercept, twice the y-intercept would be -4. So it's not equal to 4. So this picture doesn't work.
The one on the right.
Right, exactly. In other words, so far I have not been able to draw a line where the x-intercept is twice the y-intercept and have a positive slope, which is what I'm trying to do. If I can find even one such line, then I can prove that this is not true.
You can prove that A is not true.
Exactly. It's all I have to do is come up with a positive slope line where the x-intercept is twice the y-intercept. Okay.
And I don't see it.
No, I don't think I can do it. I've tried a lot. And it's important that my first attempt was this, okay? So it's important to switch quadrants. In other words, this has a positive x and a negative y. Well, how about if we come up here and do this? Well, that has a negative x and a positive y. Clearly, the x is not going to be twice the y. The x is a negative number, the y is a positive number. So if I cannot figure out a way, and this is the only way I know how to do it, I don't know of an algebraic way to solve this.
Sure.
But if I cannot figure out a way to draw it, no matter how many times I try, in other words, let's say I try this. Well, the x-intercept is negative, the y-intercept is positive. The x-intercept's never going to be twice the y-intercept in that scenario either. So I can draw it probably 4 or 5 different ways, and none of them result in an x-intercept that's twice the y-intercept.
Correct.
Therefore, I think this probably is true.
Yes.
I'm going to put a true by that. And quite frankly, that's the only way I know how to do this problem. I don't know how to do it algebraically. I only know how to do it by drawing lines. Okay, let's look at B. Again, they're saying that these statements prove that the slope is negative. So my goal is not to draw a bunch of negative slopes that agree with this. That won't prove it. My goal is to try to disprove it.
Okay.
Well, again, I'm going to draw positive slopes to try to disprove it. So let's draw a slope like this.
But every time that you go to the negative part of the domain, it's not going to make K positive.
You're right. So this also looks like it's probably true. But I can't tell it with just one line.
No.
I can draw that line over here also. In other words,
But you can do it.
Draw that line so that in one case the y-intercept is negative and the x-intercept is positive. In another case, the x-intercept is negative, the y-intercept is positive, and I can draw it where that's about it.
What about if both are positive?
I can't draw it like that. You tell me how I can draw it like that. The only way I can draw it like that is with a positive slope.
Oh, okay, because we're trying to prove that it's not negative, right?
We're trying to draw a positive slope line that agrees with that.
That agrees with B?
Yeah, and if we can do it, it disproves B. If we can't do it, then I'm going to assume that B is true.
The product of the X and the Y is positive. So I see that we can't do it.
I agree with you. I don't think we can do it either. In other words, I've tried multiple scenarios, and this is not one of the scenarios here. That's a negative slope line.
Right.
All I'm doing is trying to find a positive slope line that disproves B. In other words, if I could find a positive slope line where the product of the x-intercept and the y-intercept was positive, then it would disprove B. But I can't do it. No matter how hard I try, I can draw my line like that, I can draw my line like that, I can draw my line like that. Every positive slope I can think of that doesn't go through the origin, the product of the x-intercept and the y-intercept is negative. No matter
what does it mean by does not pass through the origin?
Means this line doesn't go through. There's the origin.
Okay, that's what I thought. Okay.
Yeah, because if it goes through the origin, it makes some of these statements unmeaningful.
Okay.
In other words, if it goes through the origin, the x-intercept is the same as the y-intercept.
Right.
So you wouldn't be able to use these tests.
Sure.
So the real question is, how many different times do you try it before you give up and you say that has to be true? And I don't know what the answer is.
Okay.
But I know there's only a few ways to draw positive slopes. In other words, I can draw a positive slope like that. I can draw a positive slope like that. I can draw it like that. I can draw it like that. Or I can draw it like that. Well, every single one of those positive slopes, the product of the x and the y-intercept is negative.
It's negative.
So at this point, after trying all of these variations, I can't disprove that statement B. Therefore, I'm going to call it true.
Mm-hmm.
Now, that's a little bit fuzzy logic because I'm not able to try all combinations, but there's not really that many combinations when you're talking about the slope of a line on the xy plane. There are an infinite number of combinations, but not really. In other words, the combinations involve making the x-coordinate positive and the y-coordinate negative.
Mm-hmm.
Or I can make the x-coordinate negative and the y-coordinate positive.
Mm-hmm.
or nothing else. In other words, if I try that, that's a positive x coordinate, negative y coordinate. That's the same as that. So that's
what if it's a new?
not really,
What if it's a zero slope?
good question. I hadn't looked through at that. Very interesting. Let me look at that. That actually may have brought something up that I hadn't thought of. So let's first of all see if that satisfies our conditions. Okay, it doesn't pass through the origin.
No.
Oh, I like this. X-intercept, there is no x-intercept.
Oh, so that's the problem.
Well, yeah. In other words, the x-intercept is not twice the y-intercept. But I can't really use the horizontal line to test it because there's no x-intercept.
Right.
So this statement assumes there is an x-intercept.
Right.
But let's look at it there. Again, the product of the x-intercept and the y-intercept is positive. Well, in this particular problem, the x-intercept wouldn't be zero. It just wouldn't exist. So I'm not sure I could figure out the product of the x-intercept and the y.
No. Okay.
Horizontal lines and vertical lines probably we can eliminate from the possibilities.
Okay.
Okay. So far we got that true and that true. Now the toughest one is C. Just draw a normal line. In fact, it might not be a bad idea to draw a negative slope line just to see what they're talking about. That point is A comma B, and we'll call that point R comma S. Okay?
Okay.
Is A minus R positive or negative?
A minus R. Well, the way you've drawn it, it would be positive.
Well, let's see. If I
oh no, because they're both on the negative. They're both X.
A minus 2.
So no, they're not.
So A minus R is negative in this drawing that I drew. Okay, right. I'll put a negative there. How about B minus S?
It's negative.
No, that's a big number.
Oh wait, they're positive, right.
That's a positive number. Negative times a positive is negative.
Correct.
So with this particular line that I drew with a negative slope, indeed that is true.
Mm-hmm.
So now can I draw it with a positive slope where it's not true? That is the question. Well, let's draw some positive slopes. Oops, can't go through the origin. And let's put a point there called A comma B. And we can put our other point anywhere, and I'm going to try it at various spots. Tell me what A minus R is. Is it positive or negative?
A minus R would be positive.
How about B minus S?
Also positive.
Which is positive, greater than 0.
Mm-hmm.
So this line doesn't prove it, right?
Correct.
Let's put my RS in negative territory.
Okay.
That's a good option because my first RS was in positive territory, both of them. So if I try negative territory, I'm going to learn a different circumstance.
Mm-hmm.
What is A minus R, positive or negative?
I don't know for sure.
Well, the only way the way you can figure out is put a positive number on A, we know it's positive. Put a negative number on R, we know it's negative. Now
It's going to
subtract
be
it.
positive.
Okay, it's always going to be positive. In this scenario, no matter where my RS is, I could put it way down here and A minus R is still positive.
But if it were -6,
Still be positive. That would be a positive 11.
5 minus
5
6.
minus a negative 6 is positive 11.
Oh, it's a positive. Okay.
Okay. Now, what is B minus S? B is positive. S is negative.
So positive?
Again, not less than 0. Now, at some point, you kind of have to give up on trying to disprove C. But
So everything's true?
I'm not quite, I think it is, but I'm not quite ready to give up yet. I'm going to try, and
Okay.
I'm not interested in applying negative slopes. In fact, if I found a negative slope where this was not true, well, I couldn't find one. I looked. Not sure what it would mean. But let's try one more positive slope up here.
Okay.
Because now I can put my A and B where A is in negative territory and B is in positive territory. And I can put my RS in the same place where R is in negative territory and B is in positive territory. Now, what is A minus R? Positive or negative? And
A minus
yeah,
R.
the way to figure it out is just to put in some numbers that make sense. That could be -2 for an A, that could be -4.
So -2 minus -4 is what you're saying? That's going to be positive, right?
Exactly, always. And what is B minus S? They're both in positive territory.
They're going to be positive too? Positive as well?
Again, that's a positive. So every slope I have drawn with a positive slope, this turns out to be negative. A minus R times B minus S. And guess what? It doesn't matter if I make that R and that S and that A and that B. Does not change the sign. Regardless of which one is above the other or where they're at relative to one another. In other words, if you did the math here, you would get A minus R has to be negative, and B minus S would also be negative. Negative times a negative is a positive. I still get a positive.
Right.
So it doesn't matter how you orient the positive slope line or where you put the R and the S or the A and the B, I always get a positive sign when I do A minus R times B minus S, which
Okay.
kind of tells me that if I get a negative sign, I got a negative slope. Now, we can test one just to make sure that it makes sense. And this time, let's put the negative slope there. And let's put AB, RS. So this should come out to be negative. A times, or A minus R times B minus S. Well, what's A minus R? Is that negative or positive?
Well, A is positive and R is...
A is actually negative.
Oh.
Right? A is the...
Oh, so A is negative and R is positive, right?
which is going to give me a negative sign.
Okay.
No matter what numbers I put on there. If I have -5, -3, that's negative. And B minus S is positive. Because B is a positive number, S is a negative number. So when I take B minus S, I get a positive number always. Well,
so -5 minus 3 is -2?
-8. Way to handle this.
-8.
Turn it
Okay.
into an addition problem by making it look like that.
Okay, right. That's what I thought. Okay.
Okay. And B minus S is positive also. So with my negative slope line, I do get a product that's negative.
Mm-hmm.
So I've tried every possible positive slope I can try. And I've tried one negative slope, and this appears to be a true statement.
Yes.
Furthermore, you only have 2.5 minutes to do these problems. So it's not like you can spend 20 minutes drawing every possible combination.
Right.
You kind of have to be able to draw a few and call it a day. And so what I get on this is a true, true, true.
Okay.
Yes, yes, yes. But notice how much time I spent on this problem.
Yes.
I don't know what the answer to that is. I wish I knew a simpler way to answer this problem. But they structure this problem this way for a reason. I don't know that you can solve it algebraically or using the definition of slope even. Perhaps you could. I don't know. I didn't really give it a lot of time trying to figure out a different way to come up with the answer. Usually on problems like this, my technique is to try to disprove it. If I cannot disprove it, then I'm going to call it proven.
Okay.
Okay?
That makes sense.
Well, I don't know if that's the best answer or not, but that's the one, the way I would do it if I was taking the test. And whether I would do as many examples as I did, in other words, I don't know how long I took, probably 15 minutes on this problem.
Yeah, that's about right.
Yeah, whereas if I was doing it on a test and time mattered, well, I'm going to do, for question A, I'm going to look at that positive slope and that positive slope and call it a day.
Okay.
And the reason I consider those drastically different is because that has well, excuse me, if I label my points, that has a positive A and a positive B. That has a negative R and a negative S. This has a positive A and a negative B. This has a positive R and a positive S. So these two lines actually allow me to cover most any kind of positive slope, wherever A and B are or wherever R and S is.
Right.
Sorry, that was for C. So that's what I would do. If I'm doing A, I would just, again, the most important part is to draw positive slopes and try to disprove it.
Okay.
Excuse me, that's a negative slope. I might draw that slope right there. And notice that the x-intercept is not twice the y-intercept. Or I might draw this slope there, where, yeah, the x-intercept looks about twice the y-intercept, But it really isn't. The x-intercept is 4, the y-intercept is -2. So the x-intercept is not twice the y-intercept.
Right.
So after drawing those two positive lines, I probably give up and say, yes, A is true. That's the way I would do pretty much all of these. And then it's a question of how much time you really want to give to that problem. Now, I don't know where this came in, but this is a beginner problem here. This is easy.
Okay.
So I guess one thing that tells us is that higher number problems are not necessarily easier or harder, excuse me, than lower number problems, which typically actually is the case. In other words, if you give me problem number 25, I'm going to tell you that there's like 4 times more likelihood that it's tougher than problem number 1. But this is proof that it's not always true, because this is really an easy problem.
Okay.
What am I going to do to figure out? This is how far away the freight train is from Centerville based on time. This is how far away the passenger train is from Centerville based on time. So if I wanted them to be equal distances, what would I do?
Equal distances?
Yeah,
okay.
I want to know, when will the trains be the same distance from Centerville?
I have no idea.
Set them equal to one another. Remember what this is. That's the distance from Centerville. This one is the distance from Centerville. That gives the distance from Centerville, those equations. So
negative 20t plus 150 equals negative 10t plus 115?
Exactly. In other words, when at noon, when t is 0, the freight train is 115 miles from Centerville. The passenger train is 150 miles. Well, they're not equidistant. But as time passes, the freight train gets closer to Centerville, and so does the passenger train. But the passenger train is actually moving faster. So there is going to be a point in time where they are equal distance from Centerville. And the way you do it is quite simple. You set the two equations equal to one another. You solve for t.
They're going in the same direction?
Actually, they're not. They're going, here's Centerville, here's one train going that way, and here's another train going that way. But they're at different speeds.
Okay.
And they don't actually tell you the speed, but they do tell you the distance from Centerville is based on time.
Yeah, I just wasn't sure which direction they were going.
If I said, where's the freight train at the end of 1 hour? It's 105 miles, right? In other words, if you plug in 1 for t and solve that, the freight train is 105 miles from Centerville after 1 hour.
Oh, okay.
Well, where's the passenger train? It's
130 miles.
Well, they're closer together. They were 35 miles apart. Now they're only 25 miles apart. So as time passes, the passenger train, which is going faster, at some point in time, it reaches a point where it's the same distance from Centerville as the freight train. But you don't really need all of that logic. All you need to know is that if this function tells you the distance from Centerville, and this function tells you the distance from Centerville, and they want to know where they will be equal, then you set one function equal to the other.
Okay.
Solve that function, and you get that.
So how did you do that?
I move the 20t to the left, and I move the
And then
150
make
to the
10t.
right. It's kind
Oh, I
of the
see.
way I
Okay.
think about, it's the way I do all my equations, is I think about moving terms to the left and to the right, or to the other side of the equation. Well, if I want to move the 20t, the negative 20t, to the left side of the equation, I just have to change its sign. So now I have
Right.
minus 10t plus 20t, that gives me 10t.
Right.
Same thing with the 115. If I want to move it to the right side, I change its sign, add it to
Mm-hmm.
150, and I get 35.
Okay. So would that be 330 then?
Exactly. That's the trickiest part of this problem. When I said this was an easy problem, what I really meant was the first part of it was easy.
Mm-hmm.
Figuring out how many hours have to go by until they're equidistant is easy. Translating that to a time is a little harder. In other words, if they wanted to make this problem much better problem, they would have put this answer on it. See why?
Oh, yeah.
Then it would have been tricky.
Exactly.
Then it would have been tricky. The way they
Yep.
did it, they gave you a break. They really didn't put the trap answer on there. In other words, once we come up with 3.5 hours, the only answer that makes any sense at all is that one.
Okay.
Okay? All right, we might have just enough time for this problem here. This is kind of a statistics problem, but it's one that you can figure out without any knowledge of statistics.
Okay.
Suppose first quartile means.
What?
That,
Oh,
that's
like
a
the
statistic.
first 3 months of the year?
No, it's the first quarter of the employees.
Oh, right.
In other words, it's the first 20 employees. We have 80 employees, all with a different salary. Mark's salary is the second highest of the lowest 20. So let's draw our salaries out here. There's the lowest. There's the highest. We have 80 salaries between the lowest and the highest, counting the lowest and the highest. Okay? First
Mm-hmm.
quartile means the first 20. Second quartile means the second 20. Third quartile would be the third 20. Last quartile would be the fourth 20. So if Marx is the second highest in the first 20, what is he relative to the whole company, all 80 salaries? See, first, second, 80th,
Fourth?
he's 19th. He's the second highest salary in the first 20.
Oh, okay.
So he's the 19th highest salary in the company. This number they give you is irrelevant.
Mm-hmm.
And they're good at that. They're good at making up problems and sticking numbers in there that don't have anything to do with the answer.
So I have a question about this. I'm just conceptually a little confused here.
Go ahead.
If there are 80 employees
Mm-hmm.
and 4 quartiles,
Mm-hmm.
you say he's the 19th highest.
Well, he's the second highest in the lowest quartile. And there's 20 in each quartile. So if he's the second highest, he's got to be number 19.
Oh, in the first, okay, got it.
There's 20 people. There's 20 salaries in that quartile.
Okay,
The
now I
second
understand.
highest. Okay?
I was looking at the whole 80, not just within the quartile. Now I understand.
That's important, though, because it's important to know he's the 19th in the whole company. Because now the rest of the problem says is that they hire 8 new employees, all with lower salaries. So now our quartile changes. Now we have 88 people. And now each quartile has 22 people in it. Well, he was the 19th lowest paid salary. Now he's going to be the 27th lowest paid salary because they just hired 8 people that were less paid than him. So he moves up the salary ladder by 8 spots.
So where is he now? Is he in the second quartile?
He is. The quartiles changed because now there's 88 people in the company. So the quartile is only 22 people. And he's the 27th highest salary, which means he's the 5th lowest.
And that's because
second quarter.
He's the 27th because there are 8 lower than he is.
Exactly, and he started out in the 19th.
So add 8, and that makes 27. Okay.
Because everybody they added had a lower salary than him.
Okay.
So he went from being the 19th lowest to the 27th lowest.
Okay.
And if you break up the 88 employees into 4 quartiles, each quartile is now 22 people.
Right.
Which, since he's in the 27th spot, he's definitely in the second quartile, and he's right there.
Right.
So he's in the 5th lowest salary in the second quartile. And notice that none of
lowest salary in the what?
The second quartile, which is this quartile right here. That's the second lowest that's the second quartile.
He's the 5th lowest because 22 plus 5 gives you 27?
Exactly.
Got it.
If he had the 44th lowest salary, he'd be the highest person in the second quartile.
Okay. Got it.
Okay. That's probably a good place to stop.
All right.
Question 13. Let me just check real quick what the next one is. It'll help me remember where we left off. 14 is actually fairly easy. So is 15. So these definitely don't necessarily get harder as they get higher.
Right.
And the biggest thing that tells you is that you want to make sure you see every single problem. You do not want to run out of time without having seen problem number 25.
Right.
That's the last one. Because it's possible 25 could be an easy one that you could get done in 30 seconds. And if you don't see it, if you don't get to it, you spend all your time on the harder ones, you've given up points.
Exactly.
So that's why I say that it's very important to pace yourself so that you make sure that you at least read every single problem once.
Exactly.
Okay. Carolyn, I will talk to you Sunday.
On Sunday. Okay. Thank you very much.
You're welcome. Bye-bye.
Bye.